Okay, welcome to 5.3 in graphing radical functions. So this is one of those type of lessons that's in a lot of other different units. And so we did this with linear, we did it with quadratic, we'll do it with exponential as well. But it's all about transformations. So graphing functions based on parent functions. And so this is something that we should already kind of be familiar with a little bit. And so we'll remind you of some things, and hopefully this is fairly simple. So just before we get started, I just want to let you know that this does have square roots and cube roots, and you could graph any kind of root, but we're really going to focus on just square roots. We're not going to be graphing cube roots or fourth roots or fifth roots and above. We're going to focus just on square roots. And so this is the parent function. This is what a square root function looks like. So here's f of x and the square root of x. This is the standard graph. Every function has a standard graph. With parabolas, it looked kind of like this. With linear, it was diagonal across the middle. But with radical functions, it starts at the origin and kind of has this kind of shooting off look to it. And the reason why it starts here and only goes this way is because of the nature of radicals. You have to remember that we can't have negative radicals, or negative square roots, so you won't see this go into the negative. It starts from 0 and goes positive because you can't do the square root of a negative number. And that's why that's there. We will also be writing domain and range here, which we'll talk about. But remember from probably 8th grade, freshman year, domain is the x values, usually talking about from left to right. So when we look at the x values, it starts at 0 and goes up from there, and so we write that as x is greater than or equal to 0 because every x value here is going to be greater than or equal to 0. You wouldn't say it's less than, obviously, because then it'd be negative. Your range, if you don't remember, is all of your y values. So you're looking at this way. This graph is going to again start at 0, 0. And it's going to go up forever. Not only is it going to the right forever, but it's also going to be going up forever. And so starting at 0, going up, this would be y is greater than or equal to 0. And we will, again, talk about domain and range as we're graphing these. So what we need to know here is that everything follows, and you can write this up here in the top right-hand corner. Everything follows the form that I gave you in that a parentheses bx minus c plus d. If you remember this from first semester, each one of these did different things. For example, c moved it left and right. And you just had to be careful with this negative sign. It always moves it opposite. Opposite of what you think it would be. And the number out here always moved it up and down. A number in here, I told you guys we're not going to have a b of x, though you're going to see it down below here, but we're not going to have a b this year at all. I told you guys that last semester. You're not going to have a number here. This is horizontal stretching and shrinking, but we won't see that. A is vertical stretching and vertical shrinking. Also, if this is negative, it is flipped, or it has a reflection across the x-axis. So this is the same function. The only thing that's going to look different here is instead of parentheses, let me just use the highlighter, you're going to have a radical. And so it follows the same rules here. So anything on the radical, this is going to move it left and right. Just be careful with this. It's opposite. this is going to move it up and down. Anything on the outside of the radical will be a vertical stretch or shrink. Or if it's negative, it will be a reflection across the x-axis. So we're going to practice some of these. And also, by the way, just so you know, you are going to need a graphing calculator, and you are going to need to be able to graph these, and it's going to help to have a graphing calculator. So just to review, I'll keep that thing up there in the top right hand. So horizontal transformations here. So remember, anything that's on the inside is going to move it opposite. So a -2 on the inside actually goes 2 to the right. A +3 goes 3 left. This is all just review. This is on the outside of the radical. So this is going to be up and down. So this will be up 7, down 1. Again, you're not going to have this on the inside. You're not going to have a number here on the inside, but this would be a horizontal reflection over the y-axis. Remember, the negative on the outside is a vertical reflection, so over the x-axis. And then, again, you're not going to have a number here, but this is horizontal stretching and shrinking. We're going to focus on the numbers on the outside. Remember, if the number is greater than 1, we have a vertical stretch by a factor of 4. If the number is less than 1 or a fraction or a decimal or something like that, then it is a vertical shrink by that factor. And so, again, same thing. Everything is exactly the same as when we did with quadratics and when we did it with polynomials and when we did it with linear lines. And so all we're going to do is be graphing these things. So this shouldn't take long. What I'm going to do is I'm going to graph the parent function here in black, just so you have it. The parent function is a standard square root. A standard square root, we have to graph the parent function. We'll start at 0, 0. And you can graph these pretty quick because you know that the square root of 1 is 1. So I know 1, 1 will be a point. And then I know the square root of 4 is 2. So I can go to 4 and know that that's 2. You could even do the square root of 9 is 3. And so we can plot these pretty accurate by doing some sample square roots. So square root of, right here I have square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So I can get, that's a basic parent function. And so what I'm going to do here is I'm going to do this transformation. And so this is going to shift it to, since it's on the inside, it's left and right. This will be right 3 and then up 4. So I'll do my new one in, we'll do red. So I have right 3 up 4. So I'm going to go right 3 up 4. Here's my new origin. And so I can go 1, 1 as a point. I can make this point go 1, 1, and then I have 4, 2. So 1, 2, 3, 4, 2. And I can graph my point, or my, whatever, my radical there. You can also, one thing to note here is you can just put this into your graphing calculator and graph it and then look at the table. If you remember, when you go to graph, if you hit second in table, you can look at the table of values so you can see all the table of values for this. And I'll show you what that looks like. Let's see, actually, we could just do it right now. I'm only going to do this for one problem because we don't need to do this for every single problem. You'll get the point. Why is this not working? There we go. Let me go back. Home. My TI-84 calculator. That's not what I wanted. There we go. So again, we can just put this into our graphing calculator. Y equals, and I can just do the square root of x minus 3. We need to be careful because that plus 4 is not under the radical. So if we just hit the right arrow, it'll take us out, and then I can just put positive 4. Now I could graph this so I can look at it. That looks about right, but what you may want to look at is the table of values. So you hit second and graph, and you can see where this starts. And so it gives me all the points. So I have a point of 3, 4, 4, 5. I also have a point of 7, 6. And so those are the points that I already have there. Now, we're going to describe this transformation. When you describe the transformation, you would just say that it moved right 3, up 4. Same thing that you did before. But one thing that's going to be new is going to be writing the domain and range. So domain is your x values. Since this x value here starts at 3, the x value, and you can look on your calculator here, the x values start at 3 and go up from there. So we would just say x is greater than or equal to 3. The range is the y values. So again, you could just look at your y values on your graph and see that it starts at 4, or you could just look over your calculator and you see that the y values start at 4 and go up from there. So it would just be y is greater than or equal to 4. All right. Moving on to another problem here. So again, I'm going to just, for sake of time, I'm going to copy our parent function and put it over here. There we go. Just to save time again. And now I'm going to graph this. So this one might be a little bit more challenging because of the 2 out front. You might not know how to graph this with a vertical stretch in there, because it's not just left and right and up and down. So this is again where an opportunity where you could just plug it in your calculator. So 2 and square root of x plus 1, and then minus 2 on the outside. And so now I can see that's what it should look like. Okay, it looks like it's going maybe left 1, down 2 or something like that. But let's look at the table of values just to make sure. So it looks like I do have a point at 0, 0 again. But I also, if I go up, you want to start where the errors are. That's your first point is going to be right after the errors. So I have -1, -2 is a point. And then I also, looks like I have 3, 2. So right here, I could also plot another one if I wanted to by going down. Let's see. Oh, I got 8, 4. That's another one, 8, 4. And so I can graph this like that. And so there's my transformed graph. So I would say this is a vertical stretch. Okay, a vertical stretch by a factor of 2. This moves it left 1 and down 2 when you describe your transformation. In doing the domain, again, you can, you could do, let's do domain and then range. Domain is the x values. So again, you can look at your graph or just look at your calculator. The x values start at -1 and go up from there. So x would be greater than or equal to -1. The range looks like on the graph it starts at -2, but you could also look at your calculator and see that it starts at -2. So you would say that y is greater than or equal to -2. Now, it might not always be greater than. We'll do a particular problem over here where things go different directions. We'll just do one more here, and then D you can try on your own. But C here, so this has, we notice that a negative on the outside, so we do have a reflection over the x-axis, along with it moving right 3 and up 2. So again, I'm going to pull my parent function because we do have to draw our parent functions each time. And that didn't work. There we go. So there is our parent function right there. And now I'm going to draw the actual function. Again, if you don't want to do the shift and do it in your head, the shift left and the shift up to, again, many of you may just opt to do this in your calculator. So negative square root of x minus 3 and then plus 2. Oops. See, I didn't want to do that. I need to get out of there. Plus 2. Now it's out. And then I can graph. And you'll see this looks weird because it's upside down, but also it's kind of out in space. So I can look at my table of values. Remember, you start with the error, right after the error, and I can just plot my points. So I have 3, 2. So 3, 2 is a point, and then 4, 1 is a point, and then 7, 0. Let's see, 7 zeros right there. I don't know if I have any more points. Yeah, 12, and I don't go out to 12. So that's all I have, and so this is going to be kind of weird here. I got to go, like, upside down. That might be a little hard to do. But we still need to do domain and range here. So I'll do it down here, domain, range. That's sorry, just being sloppy and trying to go quick here. Domain, again, it's where the x values start. The x values do start at 3 and go to the right, or they go up with this function. So it is going to be x is greater than or equal to 3. My y values look to start. Now, this is where you got to be careful here. The y values start at 2, but they actually go down. Look at the numbers in the y. They are decreasing from 2. So I would need to say y is less than or equal to 2, because that's everything less than 2. And that's how we write domain and range, and that's how we graph radical functions with using domain and range. You could try D if you want to. It's a simple just shift to the right one, and that